All right, so this is the key to worksheet section 2.1 part 2. And so number 1 says fill in the blanks so the statement is true. All right, so two sets that contain the same number of elements are called equivalent sets. Equivalent sets. The number of elements in a set is called the cardinal number. Cardinal number. Two sets that have the same cardinal number can be placed in a one-to-one correspondence. One-to-one correspondence. All right, number 2. Determine whether the set is empty or not empty. In the blank, write empty set or not an empty set. Okay, so you have the set builder notation. So you have the set of x's such that x is less than 4, and at the same time, x is greater than 7. All right, so here's the thing. Can you in some kind of roster form tell me any numbers that's less than 4 and at the same time greater than 7? No, there are no numbers less than 4 and greater than 7. All right, so that's an empty set. So empty set. B, the set of natural numbers, and you want the natural numbers to be between 4 and 9. So is this an empty set or not empty set? It's not empty set because you can list them. They are 5, 6, 7, and 8, right? So that's not empty. All right, not empty. C, the set of x is such that x is a U.S. state whose name begins with the letter L. All right, well, for example, Louisiana, right? Louisiana, so that's not empty. All right, Louisiana. All right, D, the set of x's such that x is a planet in our solar system whose name begins with the letter A. There is no planet in our solar system that begins with the letter A, so that's an empty set. All right, this one, the set of x's such that x is the number of planets in our solar system whose name begins with the letter A. Let me read that again. Oh, okay. So the difference between these two is this. So this is the number, the set of x's such x is a planet in our solar system whose name begins with the letter A. All right, so there is no planet that begins with the letter A. This, though, says x is the number, so that's a little tricky. X is the number of planets in our solar system whose name begins with the letter A. So what's the number in our solar, how many planets in our solar system has a name that begins with the letter A? 0. So I have a roster with the number 0. So that is not an empty set. So that's not empty because I can tell you how many there are. There's 0. Okay. So that one was tricky. All right, 3, determine if the set is finite or infinite. So the set of natural numbers, and so how many natural numbers are greater than 20? Is that a finite or an infinite number? Well, if you start listing them, that's 21, 22, 23, and so on. That's an infinite set, right? B, the set of natural numbers and the natural number is less than 20. Well, if we look at them, that's going to be 1, 2, 3, 19, and 20, right? So I can count those. I'm sorry, up to 19. I can count those. There are 19 of them. So that's finite. All right, let's look at the next one. Okay, here you want to find the cardinal number. So you're going to find the cardinal number of these. All right, so you have this set A, and it consists of 1, 2, 3, 4, 5. So remember, the cardinal number is the number of elements in the set, and only list them once. Only count them once. If it repeats, count them just once. So 1, 2, 3, 4, 5. B, let's see, I mean, so you have, and again, it goes by 5, so I kind of messed that up as well, didn't I? So 1, 2, 3, 4, 5, 6. So that's 6. All right, C, the set of x is the month of the year that begins with the letter P. So how many months in the year begin with the letter P? There aren't any, right? So what's the cardinal number? So how many months are listed here? None. So the cardinal number is 0. 0. D is the a set that only has this word 7. So how many elements are in this set? Just 1. E, the number, so A is a natural number, and you want all the natural numbers that are between 4 and 10, so it helps if you list them. So in roster form, that's going to be 4, 5, 6, 7, 8, and 9. So how many elements are there? 1, 2, 3, 4, 5, 6. There are 6 of them. Here, do the same thing, list them. So the natural numbers, and you notice there's an equal sign in both of those. So that's 7, 8, 9, 10, 11, 12. So that's 1, 2, 3, 4, 5, 6. That's 6 also. All right, C, the set of x's less than 7. And at the same time, you want those numbers to be greater than or equal to 10. Here's your set, right? How many elements are in that set? 0. There are no numbers that are less than 7 and greater than or equal to 10. So how many elements are in that set? 0. All right, 5. For each pair says determine whether the sets are equivalent or equal. So for part A, you're going to say yes or no. Yes, it's equivalent. No, it's not equivalent. B, you're going to say yes, it's equal. No, it's not equal. All right, so remember, equivalent sets have the same cardinal number. That's all that is. Equivalent sets have the same cardinal number. Equal sets have the same elements. All right? Okay, so number 1. So to answer part A's here, you have to look at the cardinal number. So what's a cardinal number of this one? 1, 2, 3, 4, 5. So I'm going to go ahead and do this here. So cardinal number here is 5. Keep that in mind. Cardinal number here, 1, 2, 3, 4, 5. So that's 5. So those are equivalent. So yes, they are equivalent. Let's see, they're equal. Are they equal? No, you can obviously see they're not equal. They don't have the same number of elements. The same elements. So no. Okay. Here, the cardinal number is 4. Here, the cardinal number is 1, 2, 3, 4. You only list them once. So yes, they are equivalent. Are they equal? Okay, 1's in here, 3's in here, 6's in here, 8's in here. So do they have the same elements? Yes, they do. So they're equal. Doesn't matter whether they repeat or not. 3. All right, so we may have to list those here. So let's see. You want the natural numbers, and you want the natural numbers to be between 7 and 12, including 7. So that's going to be, so A is this. A is 7, 8, 9, 10, 11, right? Okay, here. B is going to be between, you cannot include 2 because there's no equal sign, so you're going to say 3, 4, 5, 6, 7. All right, so let's answer B. The idea of equivalent, they have the same cardinal number, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So yes, they are equivalent. Are they equal? No, they don't have the same elements. Okay, here, do the same thing. Let's list them. So A will be 72, 73, 74, 75, 76, 77, 78, 79, and 80. B will be, all right, so you want all the natural numbers between 71 and 81. So there's no equal sign, so the next one will be 72, 73, 74, 75, 76, 77, 78, 79, and 80. All right, so do they have same cardinal number? Yes, they do. Are they equal? Yes, they are. All the elements listed here are the same as all the elements listed here. Okay? All right, so that is the key to section 2.1, part 2.